Today I am going to start parallel circuits. Parallel circuits. Parallel circuits means every resistance is having starting and ending points. One is starting, second is ending. Another resistance, starting is 3, ending is 4th. Similarly, starting is 5, ending is 6. Like the terminals we are marked. This is a terminal, this also terminal, this also terminals, 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 terminals. If we are connecting these all starting point together and all ending points together, connected and energized with a supply. This is called the parallel circuit. R1 resistance between 1 and 2 points. This is R2. This is R3. This is the voltage applied to this. So for every series or parallel circuit, first you have to calculate total resistance to get the current, total resistance. How to get? One formula is there. 1 by R1 plus 1 by R2 plus 1 by R3. This is then you will get the total resistance of the circuit. Next, the current flowing in the R1 is I1, current flowing in R2 is I2, current flowing in R3 is I3. So this is the total current. So the current flowing in the resistance 1, I1 is equal to V by R1, I2 is equal to V2 by R2, I3 is equal to V by R3. This is individual branch currents. So if you want get the total current, I is equal to I1 plus I2 plus I3. This is called the total current. If total current is also equal to voltage by RT, so these two must be equal always. This is called the calculation of currents for individual branches in a parallel circuit. The voltage across all the parallel elements are equal, so voltage is constant for all the branches. Similarly, current is constant in all the branches in the series circuit. For our reference, I am giving an example, a problem, parallel network, parallel circuit. Find the total resistance RT, calculate the source current, means total current through each branch. So each branch, current in each branch. This is the determination to calculate RT, IT and current in each branch. The given circuit as shown below. This is the circuit. 3 resistances, another resistance, another resistance. The 3 are connected in parallel to a voltage of with a voltage of 24 volts. The R1 is given 10 ohm. This is 10 ohm. And R2 is equal to 220 ohm. This is 220 ohm. And R3 is equal to 1200 ohm. So first of all you have to calculate the RT according to our formula 1 by 10 plus 1 by 220 plus 1 by 1200. It will give the total resistance. After calculation you will get 9.49 ohms. This is the first answer. Next, source current means total current IT is equal to V by RT according to formula. V is equal to 24 and RT is equal to 9.49 is equal to 2.53 amperes. And branch currents in the sense I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. V by R1 24 by 10 is equal to 2.4 amperes, and I2 is equal to 24 by 220 is equal to 0.11 amperes, and V3, V2, V1 all are equal to V. So all voltages are constant or same for the parallel circuit. So I3 is equal to V by R3, that is equal to 24 by 1200 is equal to 0.02 amperes. If you can add all these things, you will get the 2.53 amperes. This must be equal to, on the top we are calculating the current, that is equal. Like that you have to calculate. And for your understanding, I will give you another, I will solve another series parallel now. Now series parallel. Before series parallel, I will going to explain the current divider method. In previous case, voltage divider rule. At that condition is only two resistances with voltage is connected in series is good. But here two resistors are connected in parallel. So in this condition, voltage is here, the current I is flowing. This is total current. So the current flowing in this is I1, in this branch is I2, because this is R2, this is R1 resistances. So if we want to find the I1 is equal to total current into opposite side. For example, if you want to calculate I1 means can take R2 by R1 plus R2. If you want to know the I2, I total into opposite R1 by R1 plus R2. Like that you have to calculate. This is called the current division rule. For our understanding, I am going to give a problem for you. Simple problem. This is a parallel circuit. This is 4 ohms. This is 8 ohms. The total current flowing is 6 amperes. So what is the current here? I1. What is the current in I2? According to our formula, I1 is equal to 6 into total current into opposite 8 by 4 plus 8. Means how much? This is 4 amperes. I2 is equal to I1 4 into 8 by 4 plus, no, this is wrong. So I2 is equal to 6 into 4 by 4 plus 8 means 2 amperes. The total current I is equal to I1 plus I2 for checking. 4 plus 2 is equal to 6 amperes. So here low resistance offer high current, high resistance offer low current. See, 4 ohms is low as compared to 8 ohms. So I1 is equal to 4 amperes. I2 high resistance 8 as compared to 4 ohms. So you will get the 2 amperes. Like that you have to calculate. This is called the current division method. But simplification, always 2 resistance is better for this current divider rule. One more problem for you. This is called the series parallel circuit combination. As usually, this is the voltage connected to a resistance, and another resistance is connected as shown in figure like this. This is the circuit. The voltage is equal to 12 volts. This is 4. This is 2, 3. This is some 6 ohms, like that. Some values. This is only for our calculation only. So for any circuit, first give the names. This is A, B, C, D, E, F, G, H, I. Like that you can form. Any names you can put, not a problem for this. But solution is important. Here, if you can observe, B, D is parallel with C. That means 2 ohm is parallel with 3 ohm. So the equivalent resistance for this is 2 into 3 by 2 plus 3 is equal to 6 by 5, 1.2 amperes, 1.2 ohms. So this is the first step. After that, 4 ohms and this 1.2 ohm are in series. So the resistance of AH is equal to 4 plus 1.2, that is equal to 5.2 ohms. This 5.2 ohm resistor is parallel with 6 ohm resistor. So the resistance, total resistance RT is equal to 6 into 5.2 divided by 6 plus 5.2. You can use the normal formula also. 1 by R, 1 by 5.2, like that also same answer you will get. 6 into 5.2 divided by 11.2, 2.78, 2.78. So this is the answer. Now branch currents, how to calculate branch currents. So this is 2.78 amperes is divided into two resistances. This is 6 ohm, this is 5.2 ohm. The combination is 5.2 ohm. So this is, say, example I1, I2. So I2 is equal to opposite resistance 5.2 into 2.78 divided by 5.2 plus 6. Again calculation, 5.2 into 2.78 divided by 11.2, 1.29, that is equal to 1.3 ampere. So I1 is equal to 2.78 minus, direct you can take 1.3 minus 2.78 minus 1.3, 1.48 amperes. So this 1.48 amperes is divided into like this. Is it right? This is 2 and 3 ohm. This is 4 ohm. This is 2 ohm. This is 3 ohm. So the current flowing in this is, and this current flowing in this is 1.48. The 1.4 is divided into two categories. So the current flowing in I2 is equal to opposite side, 3 into 1.48 by 2 plus 3 into 1.48 divided by 5, 0.88 amperes. So I3, current flowing in 3 ohm ampere, is equal to 1.48 minus 0.88 minus 1.48, 0.6. So finally, if you can draw the circuit for our reference, so the current flowing is here 0.6 amperes, here 0.88 amperes, here 1.48, and this is 1.3 amperes, and this is total current is equal to 2.78. This is called the total current, 2.78 amperes. 1.3 this amperes. This is the answer. This is the way to calculate for the series parallel circuits and all these things. Very easy. Next, voltage and current sources. DC voltage source, a source that supplies a DC voltage to the circuit. Theoretically, there are two types of voltage sources are available in electrical networks. This is DC voltage source. Two are available. One is ideal voltage source. Second one is practical voltage source. Similarly, DC current source are also divided into one ideal current source. Second one is practical current source. First one is ideal voltage source, means internal resistance is 0. The internal resistance of the battery is 0. That indicates this is the battery, this is 0, this is voltage. So this is called the ideal voltage source. In this case, if we connect it to any resistance, this is R, voltage across R is equal to V. This is called ideal voltage source. Practical voltage source. Practical voltage source, second one is practical voltage source. Practical voltage source. Practical voltage source means the resistance is having some value, R. Internal resistance of the battery is having some value. So this is R. This is R1, R2. This is V. The voltage across R2 is not equal to V. Means always less than V. VR2 always less than V. That is the practical voltage source. Ideal current source. Ideal current source. Next one is ideal current source. Means this is the current source, symbolic representation I. Always current is divided in parallel. So the internal resistance of the source is like this, open. So this also 0 ohm. So this on. So an ideal current source has infinite parallel resistance connected to it. Infinity means open. The output current is independent of voltage of the source terminal. Next, practical current source. Practical current source. It is having the some resistance. This is a current source having some resistance, internal resistance, and this is the load connected to this. In parallel resistance, RP causes current loss resulting in less amount of current delivered to the load. So this I, this is say example R1, IR1, current flowing in R1 is not equal to I, but here the current flowing in IR is equal to I. This is called the ideal source. This is practical source. Practical current source. Tomorrow I will go and explain source conversion. Voltage source to current source to voltage source, how to convert. Okay. Thank you for patiently for listening and observing. Thank you very much. Please subscribe my channel. Thank you.